Oye, I call the Space Court Foundation video series to order. Welcome. My name is Chris Hearsey, and I am the co-founder of and chair of the board of directors for the Space Court Foundation. Thank you for joining us today for our inaugural video series featuring David Grinspoon. The Space Court Foundation is a 501c3 educational nonprofit corporation that promotes and supports space law and policy education and the rule of law. The Space Court Foundation produces educational materials and scholarship through the administration of two major projects, Stellar Decisis and the Space Court Law Library Project. The foundation engages in partnerships and collaborations that help grow greater awareness of space law and how disputes in space may be resolved as humans venture further from the Earth in the not too distant future. For more information about our mission, programming, and internship program, we ask that you visit our website at spacecourtfoundation.org. Today, our moderator is Letitia Zarkon. Letitia is working for the United Nations Institute for Disarmament Research. She holds an LLM in Space Telecommunications and Media Law from the University of Luxembourg and a Master II in Air Law from the University of Toulouse, One Capital. Thank you to Letitia for putting together this excellent program, and thank you very much for organizing this event today. And with that, I turn the program over to you. Thank you.
Thank you very much, Chris, for this introduction. Hello, everybody. My name is Letitia, and I will be moderating this conference today. First of all, I would like to thank the Space Court Foundation, and particularly its founders, Chris Hearsey and Nathan Johnson, for building bridges between a lot of the members of the space community all around the world. We are organizing a lot of different activities that you will hear about very soon, so I highly recommend you to stay connected and to follow the Space Court Foundation on the different social media. I would also like to address a special thanks to Daniel Porras. He came with the idea of inviting Dr. David Grinspoon for the second video of the Space Court video series. So thank you very much for supporting the project since day one. David Grinspoon is an astrobiologist who I'm sure I don't have to introduce. He advised NASA, the European Space Agency, JAXA, among other organizations, and you probably already heard about his notable works like Venus Revealed, Lonely Planet, Earth in Human Hands, and his most recent, Chasing New Horizons. He won so many awards that mentioning all of them will keep us all day, and we don't have such a time, so please connect on his website, funkyscience.net, and discover all about his recent events, news, works, and publications. Thank you very much, David, for being here with us today and for writing so many inspiring books. I am looking forward to your presentation, and now the floor is yours.
All right, thank you very much. Really glad to be here today and speaking with you all. I want to talk to you a little bit about the ways in which the space perspective allows us to see ourselves in a new context, which hopefully can help us deal with some of the challenges facing us in the 21st century and beyond. My work on this began as, my specific work on this project began when I was appointed as the chair of astrobiology at the Library of Congress for a project called Astrobiology and the Anthropocene Era, which culminated in this book, Earth in Human Hands. And I'll share with you just a few ideas from that book this afternoon. And I don't know how much of this you heard before, so I'm repeating myself a little bit. I'll sort of rush through this part of the talk. But the Anthropocene, the idea is that it's indisputable that we've been altering the Earth and we've become a new geological force on the Earth. And so while it may seem somewhat arrogant to name a geological epoch after ourselves, it's also in a way a kind of taking of responsibility and taking stock of what it is, the role that we're actually playing on the Earth, so that we can hopefully proceed in a more conscious way into the future. In terms of the geological timescale, it's proposed as an epoch. This you can see the Anthropocene way up in the upper right here above the Holocene, which is the time that we're supposedly in now, before the Anthropocene, the time since the last ice age on Earth. And the on the left of this chart, you can see that the eons, which are the major changes in Earth history, the transitional moments that there have only been 4 of, which represent new stages in the relationship between life and the planet. From the Hadean to the Archean, you have the origin of life. From the Archean to the Proterozoic, you have the sort of takeover of the planet chemically by life. From the Proterozoic to the Phanerozoic, you have the advent of complex multicellular animal and plant life. And then I've proposed that, in a sense, we may be looking at not just an epoch boundary with the advent of the Anthropocene, but an eon boundary with the advent of what I call the Sapiezoic, or the, potentially at least, the Age of Wisdom. And this is a major planetary transition if it represents cognitive processes becoming planetary processes. And then the question is, can that knowledge, that awareness that we've become planet changers, feed back and help us to become more sustainable planet changers? There's some different ideas about when the Anthropocene started. It's a subject of debate and of little consequence. It doesn't really matter on a geological time scale. Point is that we're in it. But some ideas are that with the Industrial Revolution and the accumulation of CO2 in the atmosphere, or with the first detonation of atomic bombs, of which we have a significant and sad anniversary tomorrow, with the 75th anniversary of the Hiroshima bombing. My proposal is that the Anthropocene actually started with this golden spike of tranquility base, that the geological strata that's most significant is our disturbance on the moon, which is not something that could have been done by any other species, and could not have been done by a species without planet changing. So this is the idea of the golden spike of tranquility base, when we touched the moon, this is as symbolic as any other geologic disturbance. And it's also something that our disturbances on the moon will last for geologically significant lengths of time. In terms of what we call cosmic evolution, you can look at astrobiology as the effort to put us on this map. So this is a one-page cartoon of the whole history of the universe. Starting in the upper left, we have the origin of the universe and the Big Bang, the formation of galaxies and molecular clouds, and within molecular clouds, the birth of stars. And inside the magnifying glasses there, you can see what's happening on the micro scale. So inside of stars, you're making elements, and then you're in molecular clouds, you're making simple organic molecules. And then around the orbit, around young stars being born, you're also in the afterbirth of star formation. It turns out you make planets, and on the surfaces of those planets, you're making more complex organic molecules. And then on at least one planet, we have this magic, the origin of life, and then the evolution of complex life and what we so proudly call civilization. And in a sense, with astrobiology, we're trying to understand to what degree this is a universal story. We've already established that everything on the left side of this plot is universal. That is, we know that galaxies and stars are forming everywhere in the universe. And the great exoplanet revolution of the last 20 years is the discovery that at least the top of the right hand here is also universal. We didn't know this when most of you were born, but we do now, that planets form everywhere, that basically all the stars in the sky have planets. That this is new knowledge, and that encourages those of us who hope to find life elsewhere. And the question then for astrobiology is whether these last two cartoon panels, the origin of life and the origin of complex life and even civilization, whether those might be universal processes. We have some reason to believe that they may be, but we are still very much searching for those signs. The local chapter of the story here began about 4.5 billion years ago with the formation of our sun from a collapsing molecular cloud. And in the aftermath of that, there was a solar nebula, a big spinning cloud of gas and dust, which started to form the planets by accretion. Accretion meaning the smashing together of smaller bits, and then the collection of what we call planetesimals, little planets, which then continued to collide in this very violent process of accretion until we finally had the last big pieces left standing were the planets as we know them today. So skipping ahead many billions of years, because I've already wasted a lot of time on technical difficulties, but let's imagine that we were alien astrobiologists coming into our solar system and watching this planet Earth. And let's imagine that we had really long attention spans, so we were watching this for over billions of years. What would you notice? Well, you'd see the continents drifting around and morphing like a sort of spherical jigsaw puzzle as plate tectonics worked and the planets drifted around. You'd see the climate changing, ice ages coming and going, so the polar caps sort of growing and shrinking, quasi-rhythmically growing and shrinking as the Earth switched from ice age to hothouse age. And throughout most of this history, the dark side of the planet would remain a completely unbroken black, with the occasional splash of aurora and the occasional, after the last 400 million years, when the continents became forested, you'd see the occasional forest fire. But basically the night side would be an unbroken black until very recently. Whoa, what is this? Where the night side would have suddenly lit up in just the last few hundred years on these strange patterns that sort of spread from the coastal areas outward through these nodes across the continents. And at the same time, you would have noticed this whole host of other strange and sudden changes on the planet, changes in the atmospheric composition, changes with the geometry of the land. These linear clouds start streaking across the sky, and linear wave patterns start streaking across the ocean. And very recently, in the last 70 years or so, you would have noticed something else. Little bits of the planet launching themselves back out towards space, which it would seem very strange. That in seeming defiance of the laws of gravity, little metallic objects launching off the surface of the planet and streaming out into space from whence it once all came. And if you were an alien watching this planet, you would say, oh, there's something new and very different going on here. This is the process that I call the curious anti-accretion. And I mean that in two senses of the word. Well, it's an anti-accretion because little bits of the planet are now leaping back off into space from where it all once fell. But it's curious in two senses. It's both a strange way for a planet to behave in seeming defiance of the laws of gravity and thermodynamics, but it's also the hallmark of the appearance of something new on this planet, technologically enabled curiosity, where these little metallic contraptions are not only filling the space around the home planet, but streaking off to visit the neighboring planets and sending back radio signals, agents of curiosity throughout the solar system, seeking answers to our provenance. Now, my career has been part of that curious anti-accretion, being involved in spacecraft projects and trying to understand what we've learned about the other planets, and in particular, what light that sheds on our own planet, and how we fit in. One thing we've learned from studying the neighbors, Venus and Mars, in comparison to Earth, is that both these planets, Venus and Mars, have evolved in very different ways, but they seem to have similar origins and early environments. That is, both Venus and Mars, as far as we can tell, started off with much more Earth-like conditions. And all three planets may have had warm oceans suitable for the origin of life when they were young. And then they all went off in radically different directions. Each of them in their own way went through a catastrophic change. Mars froze over and became a dry, almost airless desert. Venus became a hot house with a runaway greenhouse, and today is far too hot, at least on the surface, for our kind of life, and lost its oceans through a runaway greenhouse. And Earth went through its own radical transformation. Earth came to life. And then life kind of took over the planet and has really altered its evolution markedly. And then again, fast forward billions of years, more recently, Earth has gone through another kind of transformation, coming under the influence of a new type of geological force, the global activities of humanity defining what we call the Anthropocene. And this planetary view of evolution and the role of life and the role of intelligence causes me to ask, could intelligence like life become a planetary property? In other words, life is not something that just happened on the Earth, on an otherwise lifeless planet. Life is something that happened to the Earth, and the Earth has become a living world in many ways. Life is deeply ingrained in the functioning of the planet now, although it wasn't at first. And maybe we're in this phase now where what we call intelligent technological civilization is at an early stage where it really has not yet become well integrated into the functioning of the planet. But the question is that possible? And I partly raised this because it's a question about Earth's future, but as an astrobiologist, I'm very interested in the role of intelligence on other planets and whether you can truly have long-lived civilizations. And I've come to the conclusion that you can only do that if civilizations can figure out how to become sustainable, in that they integrate gracefully with their planetary environments and sort of learn to work with the planet rather than working against it. So this is a question about life in the universe, which obviously is an important puzzle for our current time, of humanity's current time here on Earth. It's worth pointing out and considering that we are not the first species to come along and radically change the planet. We're not even the first species to come along and in the search for a new energy source and exploiting a new energy source, completely pollute the atmosphere in a way that does great harm to other species. And now that distinction goes to the cyanobacteria, these little buggers you see here. They look innocent enough, but 2.5 billion years ago, they did such a good job perfecting their new energy source, solar energy, with photosynthesis, that they polluted the entire atmosphere with this dangerous gas oxygen, which really was deadly to the life living on the planet at that time, and they caused massive extinction. So, you know, we hear the story and we don't say, oh, those irresponsible cyanobacteria, how could they? We say, oh, well, they were just bacteria. They didn't know any better. So when we see ourselves behaving in a similar way and we react with horror, but that's because we're not bacteria and we should know better. Excuse me. But it is interesting to ask the question, what really is the difference then? It's another way of framing the question of human uniqueness. What is it about us, and what is this new role we're playing on the planet? We're not the first species to cause global change. So what have we got that the cyanobacteria didn't have? And, you know, we can come up with answers like these various human qualities of language, tool use, art, technology. These are all arguable. You can come up with exceptions from other species for all of these potentially, or these qualities of, you know, intelligence, consciousness, foresight, awareness, cumulative knowledge, responsibility. I was giving a version of this talk at the SETI Institute, and a friend of mine quipped, well, this is a list of the qualities that we don't have enough of. And that there's something to that. But collectively, these are certainly, well, these are qualities that the cyanobacteria cannot be said to have had, and that we can at least aspirationally imagine that we have, and that can help us potentially to respond to the knowledge of our planet-changing role in a new way. But we can certainly ask, are these qualities adaptive, or is this an evolutionary dead end? Or could this potentially be a gateway to great longevity? If civilization is a new planetary process, then what are its prospects elsewhere in the universe? You know, basically, this is a fancy way of saying, are we doomed because we have these qualities, or can we find a way to use these properties to help us survive? In an effort to sort of refine this picture, or get at this question of really what is unique about our mode of planetary change, I've looked at the changes in the catastrophic changes in the planets that we know of, including Earth, and tried to collect them into 4 types of planetary change. Excuse me just one second. Thank you. And these are 4 types of planetary change categorized with respect to the role of life on a planet. So the first is just what I call random catastrophes. This is, you know, when life has nothing to do with it. Life is just an innocent bystander in the wrong place at the wrong time. This is when bad things happen to good planets, and an asteroid comes and smacks into a planet and causes a mass extinction, or there's a huge burp of volcanic activity due to some random fluctuation of convection inside the Earth, which causes a mass extinction. So these are, life has nothing to do with these random catastrophes. They're just the kind of things that will happen occasionally on planets because that's the kind of universe we live in. The second category of change, what I call planetary changes of the second kind, these are biological catastrophes. When the evolution of life leads to changes in the environment, when some species becomes so successful that it leads to changes in the environment which are can be deadly for other species and can cause mass extinction. And I already gave the example, the sort of canonical example of a green leaf here to symbolize the oxygen catastrophe that happened when photosynthesis evolved. And there are other examples of this as well. The third kind of catastrophe is what I call inadvertent planetary change. And the third and fourth, I'm going to give you 2 more categories of planetary change. And both of these now are when cognitive processes start to enter into it. Both the third and the fourth kind of planetary change are changes involving cognitive processes, but there's a very important distinction between the 2. Planetary changes of the third kind are inadvertent planetary changes. And that is what happens when a species is very clever and develops technology and very good at solving local survival challenges, but so good at solving those local survival challenges that it inadvertently starts to cause global changes. And this is symbolized here by traffic. These people are solving the local problem of how do you get from Alameda to Oakland during rush hour. And the individual drivers all have agency. And we're pretty good at, I mean, driving is something we take for granted, but it's amazing that traffic works so well and there aren't more accidents. We are very good as individuals at, avoiding obstacles, stepping on the brakes, steering when you need to. But you can look at the system as a whole and ask, who is driving the global transportation system? And the answer is really nobody is in control of it. So there are systems in which we are participating, but we do not have agency. And that's really what I mean by inadvertent global change. And this is what I call the Anthropocene dilemma. And whenever your scale of influence exceeds your scale of awareness, that is an unstable situation. And then cognitively, this is similar to a child when we say a child lacks situational awareness. And so, picture a kid with a big backpack on and they go into a store and something distracts them and they turn around and the backpack smashes over a tray of whatever in the store. Your scale of influence exceeds your awareness. You don't have situational awareness. And that, in a sense, is the stage of inadvertent planetary change. And there are reasons, I won't go into this in too much detail, but there are reasons to think that for a global civilization, a species developing a global civilization, that there will always be a stage of this inadvertent global change. Because when we first started out using technology as local species, the world seemed functionally infinite. There was no reason to think the world was not infinite. And that was where we sort of developed our deeply ingrained habits. But, so some other examples of these planetary changes of the third kind, inadvertent planetary change. Well, the most pressing example right now, of course, is the fact that we are, through our industrial activities, building up the carbon dioxide in the atmosphere. This is a slightly old slide, so it should be over 400 parts per million now on the left, the Keeling curve. And the sources and sinks of carbon dioxide are well known to us, and many of the effects of this are well known to you. I won't belabor this. Down in the lower right, you can see what's been happening with the sea ice and so forth. So this is clearly the most pressing example of inadvertent global change, although there are many other examples, including another example, of course, is the problem with the ozone layer, which we first detected in the 1970s as a unintended consequence of our use of these chemicals, these chlorofluorocarbons, which we thought were these new environmentally safe refrigerants. And they are environmentally safe. They're completely inert down here in the troposphere where we live. But it's a classic example of unintended consequences because nobody anticipated they were going to diffuse up into the stratosphere, where they are not inert because ultraviolet light knocks off chlorine atoms, and chlorine atoms eat ozone. And by the way, we first detected this problem in part, or first understood it, because we were studying the planet Venus, where one long-standing mystery is what's up with the oxygen in the upper atmosphere. And one of the answers is that there's trace amounts of chlorine that mess with the oxygen cycle. And that knowledge that came from studying other planets helped us to figure out what was happening with the ozone layer. But of course, the story with the ozone layer is that once we realized what was happening, and you know, I'm going to condense a longer story with many chapters, but ultimately we got spooked enough so that there were global agreements made. And it's a success story. The ozone hole is on its way to being fixed because CFCs have, by and large, been phased out. There's some wrinkles in the story, but by and large, it's a success story. So I also use this ozone story as an example to introduce the fourth kind of planetary change, which I call intentional, because this is where the awareness of planet-changing capabilities feeds back into a modification of that behavior, and the planetary scale activities are not accidental or inadvertent, but are in fact intentional. And other examples of real or potential intentional change seen here are well, I already mentioned ozone, but on the upper right, there's the challenge of global warming, which is certainly not one we've tackled, but one that we are certainly underway in changing our energy supplies to our energy sources to ones that do not wreck the natural systems that we are dependent upon. The problem there is that the change is happening too slowly to avoid some damage and some pain, but it's undoubtedly happening. 100 years from now, we will be post-fossil fuels, and we'll be, I think, repairing the damage. And we'll think, well, that was dumb. Why did we take so long to get off of that stuff? And we'll think of it the way we think about using whale oil to power our lamps now. Like, we did that a little bit too long, and look at the damage we did. Fortunately, we didn't wipe out all the whales. That's how we'll regard our fossil fuel habit in 100 years. Looking on a longer time scale, there are threats to the biosphere that we can perceive of and imagine doing something about. And this is interesting to me because I think if there's a threat that we know we can anticipate, then we actually have a responsibility to avert it. So one of these here, symbolized on the lower left, is the threat of asteroid impact, which over the long haul is not an abstract threat. We know that there are a lot of Earth crossers in our solar system, and sooner or later there'll be another dangerous one that hits us. But fortunately, unlike the dinosaurs, we do have a space program, and we have the ability to see these objects, and I believe we'll have the ability to avert them. And in the long run, this could be a kind of payback where we could prevent the next mass extinction and the one after that, and become a net plus for the Earth's biosphere. On an even longer time scale, on the lower right, there's the possibility of dangerous natural climate change. We have this illusion that climate is something that is just fine without us, that if we take our hands off the scale, then the Earth will be this natural Edenic place. But of course, that's not true. That's an illusion because we've come along in this very unusual time of Earth history where for about the last 10,000 years, basically during the Holocene, which I mentioned earlier, the climate has been warm and stable. And that's the time during which we've become really, the time of recorded history, since we've become village and city builders. But that's an unusual time, and left to its own devices, that would not last. And we do not want to try to live through another ice age. That would be catastrophic for our civilization. So now we're talking, timescales of tens of thousands, 50,000 years. But on that time scale, it would be unconscionable to leave the Earth to its own devices. If we're here, we will have a responsibility to affect the climate. And fortunately, unfortunately, we've learned that it's not that hard for us to do. By that time, we'll hopefully understand enough so that we can have a bit more of a subtle touch with climate. If we wanted, we could look at these planetary changes of the fourth kind in a slightly more nerdy way. This is something I just put together where on the bottom scale is time scale in log years. And that means that, 3 is 1,000 years, and 4 is 10,000 years, and 6 is 1,000,000 years. And these are just some examples of global scale problems intentional problems, and are intentional solutions to planetary scale problems. You notice I've got anthropogenic global warming emission as something, or at least the efforts underway. I've got ozone as an example of something being on track. And the time scale of both of those is, on the order of 100 years or so. Slightly longer time scale, the idea of planetary defense that I mentioned, asteroid defense. I put terraforming of Mars on here, not because I'm advocating it, but it's an example of potential intentional planetary change. And I do think the fact that we're modeling terraforming on Mars, at least considering how we would do it, is valuable for sort of flexing those muscles of asking, well, how would we intentionally alter a planet as opposed to accidentally messing one up like we're doing now? What are the leverage points? What are the what are the key ways in which you could consciously, intentionally affect a planet's climate? As far as the ethics of whether we should terraform Mars, that's a longer discussion, which I'll defer. On even longer time scales, now we're talking tens of thousands of years. There's the idea of interfering with ice ages. And if you want to get really science fictional about it, about 1 billion years, there's the fact that natural global warming will destroy the biosphere of the Earth in a couple of billion years or so because of the fact that the sun is very slowly getting warmer. Now, at the very top of this, in a problem I say solved, is a smallpox vaccine. And there are some examples from global health showing that we have what it takes potentially to act coherently globally to solve problems. However, that's a sort of fraught example at the moment because we are being challenged right now by a global pandemic. And it's interesting. I taught a course actually this last semester at Georgetown about predicting the future. And we talked a lot about climate predictions and demographic predictions. And we also looked at past predictions of the present day to sort of see how well we do at predicting the future. It was a good bunch of students and a really interesting exercise. But halfway through this course, of course, the pandemic hit and we ended up doing a second half after spring break as a virtual class, which of course was not in the plan. But that also became a really interesting lesson because we had been spending a lot of the class talking about climate modeling and making the point that this vast range between the best case and the worst case scenarios, when we look at the future of the 21st century, the range does not arise from our inability to model climate. There are some uncertainties because there are aspects of the physical climate model we still would like to understand better than we do. But the big uncertainty, the big range comes from the fact that we cannot predict human behavior, and it's human behavior which really will determine what happens here. And so again, it's not just the physical knowledge that we derive of the system, but how that knowledge is incorporated and feeds back then into the human behavior, which has become part of the physical system. And it was interesting halfway through that semester when this was sort of what my class was on and what I had been discussing with the students, then we started to see graphs like this with all these different possible trajectories for the pandemic. And it was the same kind of phenomenon playing out where we could make a prediction based on our physical understanding of the way the disease worked, although obviously our understanding was imperfect and still is. But the big unknowns that meant that we could not tell which curve to expect came from human behavior, and how well we as humans integrated the knowledge of the physical system into our collective behavior. And there were a lot of other parallels too, because at the very beginning of the pandemic, especially, you really had to take the experts' word for it. You didn't know anybody who was sick at that point, chances are, and everything seemed fine. And yet the experts were telling you that this invisible thing, if you didn't change your behavior, it was going to mess you up and mess up a lot of other people and have a really dangerous effect on our society, which is very analogous to climate change. It's this sort of invisible thing on an even longer time scale, but the experts tell us, well, we really have to take it seriously and change our behavior. Of course, the difference here was that this pandemic was playing out in a matter of weeks, as opposed to climate change, which plays out over decades or years. But there were a lot of interesting parallels. And for the final paper for my class, a lot of the students, they had three choices, but a lot of them chose the option, which was to write a retrospective of the 21st century and write the story of how the pandemic changed the 21st century, written from the perspective of 50 years in the future. And that was really interesting reading the students' papers because they were all over the map. Some of them were very optimistic that the experience of the pandemic would catalyze a serious approach to climate change and other problems, and a respect for expertise and a sort of global coherence from the experience of having to deal with that problem. And then others were very pessimistic and talked about the fact that the global economy, we'd be distracted from dealing with climate change and other things by the devastation in the global economy and the need for just simple, more immediate survival needs, and the sort of splintering of the global governance that came from a rise in authoritarian governments and so forth. And at the present moment, we can see all of this playing out, and honestly, nobody knows where it's all going. One thing we can do is see the effects of the pandemic on Earth observations from space. And for instance, this is a plot of nitrogen dioxide over Los Angeles County in 2019, in spring 2019 and 2020. And nitrogen dioxide turns out to be a really good proxy for fossil fuel emissions, because it tends to be emitted with carbon dioxide, and it's not itself much of a greenhouse gas, but it tends to be emitted with other greenhouse gases in the same kind of industrial activities. And you can see a marked decrease in 2020. Excuse me. And we also have views of this over China, northeastern China. In fact, here's a video, and you can see it dissipating and disappearing as the pandemic hits and industrial activity is shut down in February of 2019. It's really pretty remarkable. I think I also have a video of a similar plot from Italy. You can see, especially over northern Italy here, when we get into the very end of this around March, it starts to decrease the amount of nitrogen dioxide. Now, it turned out that these effects were temporary, and you can already see it starting to come back places, and that's no big surprise. It's not like the decrease in emissions specifically stemming from the decrease in industrial and transportation activity during the pandemic itself is going to make any kind of significant dent in global warming. We're talking about maybe a 5% decrease in emissions this year, which, you know, is not a bad thing, but it's not really a significant contribution over the long run. But what it certainly does do is illustrate to us that our behavior collectively really can make a huge difference. You know, there are lessons to be learned here just from seeing this, and that we have choices as to how we behave. And it's worth considering as we restart the global economy, when we restart the global economy, that we are at a juncture now where we potentially have an unusual opportunity to restart and rebuild in a way that allows us to make some enlightened choices as we move into the future. Michael Mann, climate scientist, who you've probably heard of, he's written some great books. He's a very effective communicator as well as a really innovative scientist. And he wrote this recently talking about tipping points, not the tipping points that we usually associate with the subject of climate change, where we're talking about the potential for release of methane in the Arctic, or some of the positive feedbacks that could make the problem more difficult. But you know, social systems and historical systems also have tipping points. And ultimately, the problem of climate change is political and psychological, and even really sort of spiritual. It's the question of seeing ourselves enough as a global species with global problems and a need to act on that scale, and incorporating that knowledge and that perspective into the way we rebuild and continue to build our global civilization. That's what ultimately will make the difference. And so Michael Mann, and he wrote this about the fires in Australia, but he said, despite the tragedies, I'm hopeful we're hitting a tipping point, not a physical one where the climate undergoes irreversible change, but a psychological one. And these are the kinds of changes which really do, when you look at these attempts to predict the future from the past, which I mentioned my class did a lot of this last semester. These are the kinds of changes which are impossible to predict. Nobody predicts because we tend to be linear thinkers and we don't see these social tipping points coming. But these are the kinds of changes that also ultimately really have the biggest effect on history and will have the biggest effect on the future. So now getting back to this topic of the Anthropocene and what it means for global history. I think of the Anthropocene as really as the advent of a radical new type of global change, which we can call self-aware cognitive geological processes. The beginning of a time when cognitive technological processes become a key part of planetary functioning. And again, we can ask, can this become a stable long-term feature of the planet? And that leads, among other things, in my field, to the question of the search for extraterrestrial intelligence, where we sort of try to abstract this question and ask, is this a phase, the phase we're at now, where planets with complex life, a phase that they reach and are faced with this question of once you become a planet-changing species, then are you able to integrate that perception, that knowledge into the way you function in the future? And ultimately, I believe that will determine the longevity of planetary civilizations, not just on Earth, but in the cosmos. And it's very relevant because when you do the math of SETI, you realize that it's only the long-term civilizations, the ones with great longevity, that we have some possibility of detecting and communicating with. So if civilizations last for just a few hundred years, with technology, communicating technology, then they're going to be so few and far between, there's no way to find each other or detect each other. But if civilizations become sustainable and can last for tens of thousands, hundreds of thousands, millions of years, even longer, then the math of SETI shows you that it's not going to be that hard to find another one. And so this then becomes a sort of, SETI, when you look at it that way, becomes a sort of hopeful enterprise. What we're really looking for when we look for other civilizations is the survivors, those that have made it through the kind of gateway that we're at now and learned how to live with global planet-changing technology. If we find somebody, then it means that this transition that we're struggling with now is possible. So this leads to a concept that I discussed in my book of a sort of future vision for what a truly long-term sustainable civilization on a planetary scale would look like. And I give it this name, Terra Sapiens, which means wise Earth, and conclude that really in order for a technological civilization to survive, we would need to become a new kind of entity on this planet and learn to live comfortably over the long haul with world-changing technology and learn to integrate our activities gracefully with the great cycles of Earth. And I think the key for this, or a key, would be the widespread propagation of a worldview that is global and multi-generational. And the good news is I actually think, despite some of the short-term problems we're having now, that this worldview is propagating, that we're more aware than any other generation in history and more connected than any generation in history with people from all around the world. And obviously that's creating a lot of wrinkles now, but I also feel that there's an inexorable, and especially when I talk to young people and hear the way young people talk and approach things, I believe that there's an inevitable spread of this kind of a worldview. And as a scientist, I think that part of what we need to do is simply tell the truth about the world the way we observe it. And it leads to this kind of worldview. I mean, I think that science does lead to certain values that could be the ones we need to survive, in the sense that when we look at the Earth from space, we don't see a globe that looks like this with these transient and artificial natural boundaries. We see a globe that looks like this with all of the cyclic interchange and united, and changes happening on every time scale. And we see ourselves embedded in geological systems that are ancient and are inherently global. And so I think that is the worldview that we perceive of when we see Earth from space. And we've really been developing now this sort of new organ where the Earth, and this is recent, this is really within a generation, we've developed this new organ where the Earth is sensing itself. I think of this as almost like a mycelium, to use a word from mushrooms, from mycology, of that invisible net that connects and communicates amongst all the mushrooms and roots in a forest. Only this is a mycelium in the sky where we've surrounded our planet with all these sensors, where we're looking down and observing ourselves constantly and sending signals and communicating. And this is a new feature of our planet that we've constructed, and we're just starting to integrate into the way we function as a global society. I mean, to see a text from Christina Koch, an astronaut at the space station, you know, I log on in the morning and I see that an astronaut is texting a picture of moonrise at sunrise from the space station. And this is something, kind of experience that more and more of the Earth has access to now. Not everyone, but it's becoming, it's moving in the direction of universal accessibility to this kind of experience. A feature that we've constructed that I think is worth extolling for just a minute is something I wish more people knew about, the Deep Space Network, which is the way that we keep in touch with our deep space missions. Anything that's off of the Earth, far from the Earth for a significant period of time. I mean, not necessarily in Earth orbit, but out in the rest of the solar system, we keep in touch with through the Deep Space Network, which is a network of 3 antennae distributed around the Earth in California and outside of Madrid and in Australia. And they're distributed around the planet in such a way that an object, a spacecraft anywhere in space, always is in direct view of one of these antennae. As the Earth spins, they hand off the signal from one to the other. And basically, to me, the existence of the Deep Space Network drives home the point that we cannot explore far from our planet without, in some sense, being a global entity. And the effort to understand our place in the solar system and our place in the universe is inherently international. And we've now reached the point where we can see ourselves as existing on a planet which is amongst a family of planets. And there's a sequence by which, when we come to know these planets, we first see each one as a small dot, and then we explore it more closely and it becomes resolved and we see it in all its glory. But we first see them whole and just learn about them as undifferentiated places first. Extreme example of this on the left is the Discovery frame, where Clyde Tombaugh discovered the planet Pluto in 1930. And on the right is a close-up from the New Horizons spacecraft, which finally flew by Pluto in July 2015. And you see all its amazing glory of this wonderful new addition to the worlds of the solar system that we know up close. Clyde Tombaugh did not quite make it to see Pluto, but his kids were there at the New Horizons encounter with us, and that was quite an experience. So this is how we experience other planets. We see them first as undifferentiated and then differentiated. It's interesting, when we leave our own planet, we experience that in reverse. As we recede from the Earth-Moon system, the details disappear, and finally, from a great distance, we see it as that pale blue dot that Carl Sagan spoke so eloquently about. And from that distance, when we see Earth as a pixel, and lately with the exoplanet revolution, we've done a lot of imagining of what Earth would look like as a single pixel and how we would identify an Earth-like planet, since that's how we're going to experience the exoplanets and try to figure out if there's another Earth-like planet amongst them. And when we see a planet whole and as a single pixel like that, it really drives home that unity that the space perspective provides us. Here, Carl Sagan, who was actually a mentor of mine, and I worked at that laboratory he's in there in the bottom left. I worked there as a summer intern many years ago as an undergraduate. And Carl, sort of expressing this perspective of deep space and deep time, says that we on Earth have just awakened to the great oceans of space and time from which we have emerged. One of my astronaut heroes is Rusty Schweickart. And Rusty was the first person to really have some free time out there floating in space. He, on one of his Apollo missions, he was doing an early spacewalk, and they had to fix a problem, and everything had been so tightly scripted. They didn't have any time really to just sort of contemplate and meditate on what they were doing. But then mission control said, well, hold on, Rusty, just wait a few minutes while we try to fix this camera. And Rusty found himself floating out there, speeding above the Earth and watching it go by. And he had kind of an epiphany that he wrote about really eloquently later on. Oh, I was going to talk about these metaphors, but wait, since I was talking about Rusty, let me rush ahead here for a second. Rusty said, when you go around it in an hour and a half, you begin to recognize that your identity is with that whole thing. And that makes a change. You look down there and you can't imagine how many borders and boundaries you crossed again and again and again. You know there are hundreds of people killing each other over some imaginary line that you can't see. From where you see it, the whole thing is a whole. The thing is a whole. And it's so beautiful. And you wish you could take one from each side in hand and say, look at it from this perspective. Look at that. What's important? It becomes so small and fragile and such a precious little spot in that universe that you can block it out with your thumb. And you realize that on that small spot, that little blue and white thing is everything that means anything to you. All of history and music and poetry and art and war and death and birth and love, tears, joy, games. All of it is on that little spot out there that you can cover up with your thumb. Have you earned this in some way? You know the answer to that is no. You know very well at that moment, and it comes through to you so powerfully that you're the sensing element for humanity. I've used the word you because it's not me, it's you. It's us, it's we, it's life. We've had that experience. And it's not just my problem to integrate, not my challenge to integrate, my joy to integrate. It's yours, it's everybody's. So, in closing, I just want to, for a second, talk about some metaphors we use when we think about our role on the planet. We tend to often talk about ourselves in these very negative and destructive metaphors. We're a virus, we're cancer, we're criminals, we're raping the rainforest. And all of this is understandable. There's some truth to these metaphors, but it's not the whole truth. Because, you know, a cancer cell doesn't stop and get on Zoom and talk to other cancer cells and say, hey, you know, maybe we shouldn't be cancer cells. Maybe we shouldn't destroy the rainforest. We need the rainforest. They don't have that moment of realization. And we do. So not that, you know, this is no guarantee that we can behave differently, but we have at least that potential. So I'd like to think of some other metaphors that also contain truths about us that don't limit ourselves, because I worry that when we think of ourselves this way, it could become kind of a self-fulfilling prophecy and limit our modes of action in the future. Sure, this is a decent description of how we've behaved at this early phase of the Anthropocene, but I also think there's some truth in these metaphors of immaturity. We're really just babies on this planet. We've found ourselves here playing this role that we didn't anticipate and didn't ask for. And there's nobody really to teach us how to how to do this. There's no instruction manual for the planet. We have to figure it out. There's on the upper right, there's the metaphor of the unschooled driver. You find yourself driving a rig down a big rig down a road, and you sort of wake up and you go, oh, wait a minute. I don't know how to drive. What am I doing here? But you realize that everything you love and everything you care about is in the back of this rig you're driving, and you better figure it out in a hurry. That's us. We sort of find ourselves playing this role on the planet that we don't completely know how to play. So I'm just saying that there are ways to view ourselves as in a more sympathetic light. That doesn't get us off the hook. It doesn't mean we don't have this huge responsibility, but it doesn't necessarily mean we're inherently evil and flawed and incapable of dealing with our situation. It means we have to grow up and learn rapidly. So I have a few more things I could say, but I really want to wrap up and see if you're still with me and if we have any questions here. So I'll close with a quote from a hero of mine, Dr. Martin Luther King, who said, if we are to have peace on earth, and I interpret this also to mean if we are to create a sustainable civilization, our loyalties must become ecumenical rather than sectional, must transcend race, tribe, class, and nation. And this means we must develop a world perspective. And with that, I'll stop, and thank you very much.
Thank you. Thank you, David, for this terrific presentation. This is a video we have wanted to produce for months now. Since Daniel offered me your book, I've personally been looking forward to this presentation. And from the moment I've started to read Earth in Human Hands, I've understood why our planet is so precious and needs to be protected. So, as you just said, massive extinction is an important point, and for years now, the European Space Agency and other organizations are working on planetary protection, and particularly on risky asteroids. Is it a form of terra sapiens? In other words, is it one of the means Earth is using to protect itself from collisions?
Yes, that's a great question, and I do think it is. I think it's a really good example of, it's a transformation throughout the 4.5 billion years of Earth history. Our planet was vulnerable to these objects from space, and we know the really large ones hit about every 100 million years. The ones that can cause a global extinction, like killed the dinosaurs. But there are smaller ones which can still be quite dangerous, which hit much more frequently. And objects this big enough to take out a city may happen on less than 1,000-year time scales. And the fact that we've now expanded our really fragile civilization to cover most of the Earth, and we filled up all the coastlines of Earth now with heavily populated areas, and coastlines are really vulnerable to something that hits offshore and causes a huge tsunami from the impact. So this is a real threat, but the fact is Earth has been vulnerable to this threat for its entire existence, and with us now on the scene, arguably it is no longer, or will soon be no longer, vulnerable to this threat, which is not just good news for humans, it's good news for all the species on this planet. And so that really does, excuse me, mark a transition. And this absolutely is part of what I consider to be terra sapiens, the planet, on some sense, acting as, whether you want to say this is humanity acting in this way, or in a certain sense, the planet acting this way, with humans as the sensing element for the planet, as I think Rusty described it. The planet is now looking around and aware of this threat and saying, oh, we don't have to put up with this anymore. And they're actually, as you mentioned, the European Space Agency, and there are people around the world working on this problem. Appropriately, it ought to be an international effort. I believe that if we discovered a dangerous asteroid heading for Earth now, we would have at least 10 years notice, probably much more time. And I think we could build the appropriate defense system to just knock this thing off course. You don't have to destroy it. You just give it a little nudge so it'll pass the Earth. There's another danger, which is from long period comets, which sometimes, if you're really unlucky, you don't see them coming. They can show up and then, arrive in less than a year after you discover them. So for that reason, ultimately, we ought to have a space-based system that can be deployed rapidly. But I think that, the timescale in which we're now observing these objects and identifying the potentially dangerous objects and developing the technology to divert them is such that I think that we're almost at the point, maybe arguably at the point, where this threat is no longer an aspect of existence on Earth, and that's a change from the entire 4 billion year history of life on Earth, and maybe that's an early development of Terra Sapiens.
Thank you very much for this answer, David. So we just received a question sent by David Zuniga. What do you think is the most important piece of data we can collect about the Earth to ensure we continue to thrive as a species? Is there a particularly piece of space-based data that helps society during COVID-19 and helps to understand how and when pandemics might arise in the future?
Wow, that's a really great question. Interesting question. I have heard of people making space-based maps of pandemic risk. That is, there are a lot of components to pandemic risk, having to do with density of species and changes in land use and places where habitat loss is causing certain species to live in closer proximity to humans, which facilitates the jump of viruses from certain species to humans. And a lot of that's being exacerbated by climate change. And there are other sort of databases that can be correlated that use space-based data sets to really create global maps of pandemic risk. I cannot, at the moment, it's an interesting question. I can't at the moment sort of come up with one key piece of space-based data that, that if we have it or don't have it is going to make that huge difference. But I would say in a more general sense, our ability to monitor the activities of our species and our interaction with the natural world and map the changes, it alerts us to hotspots and to the loci of extreme risk, and that without those space-based observations, we'd really sort of be flying blind as we confront this new epoch of global risk, which ultimately comes from the fact that we've become this global species with such a large population and such an interconnected, the geographer Michael Mann called the homogenocene. In a certain sense, we now all the entire Earth is one interconnected biome, and so managing that requires that we have this ability to monitor ourselves in this new way.
Thank you, David. You just mentioned the notion of global species, and Bert Molloy has a related question, asking about a planet-wide governance system to allow stable Earth that is reasonably beneficial to as many species as possible.
When we see ourselves in the perspective of, what maybe is the early Anthropocene, in the larger perspective of planetary history, and realize that the fundamental nature of so many of our problems going into this new century and beyond is that, we cannot really act in a way that facilitates our own survival without some increased level of global coordination. Now, to me, that doesn't necessarily mean world government, although I'm not opposed to that idea. But I think that the notion of global governance is really key. And we arguably we're not at a great moment for that right now. But there's sort of inexorable forces leading to. I think that I'm a fan of enlightened self-interest. In other words, if the Chinese decide to burn all the coal that they can dig up in China, then it almost doesn't matter what we do about global warming. The world is toast. But of course, the Chinese, I think, aren't going to do that because they would also be toast if they did that. And not only that, you cannot breathe in Beijing anymore, or you couldn't until a few years ago. It's actually been getting better because they've realized this. So you don't need the most benevolent governments in the world all acting in perfect harmony to realize that as our technology becomes more powerful and the world becomes sort of inherently more interconnected, that there is a strong a strong motivation by the major world powers to act in concert on some of these questions that simply cannot be solved to anyone's benefit without some kind of global governance. Now, you alluded to a sort of deeper question, which is, about not just humans, but the other species on the planet. And that's vexing, where ultimately we cannot live well sustainably without a thriving biosphere. And so it's not just about us, it's about the biosphere and a good many species. But, having said that sort of kumbaya statement, there are places where the needs of humans arguably come into conflict with the needs of other species. Of course, that is less true on a planet with the smaller human population. We're, I think, approaching peak human this century. And the good news, and there is some good news if you look at long-term trends, is that the human population is going to peak and then start to decline later in this century for the right reasons, not because of an increase in the death rate, but because of a decrease in the birth rate, largely driven by a decrease in extreme poverty, and in particular by an increase in the choices of women and girls in poor and developing countries. And so if that trend continues, then human population will peak and then begin to decline. And as it declines, and nobody knows what human population is going to do in the 22nd century, but I think there is this is another interesting philosophical question. What is the ideal human population of the Earth? And I can't give you an exact number, but I can tell you it's lower than 10 billion. And as we lower our population, I think we get into excuse me, a domain where the needs of a human civilization, where we take care of one another, becomes less in conflict with the needs of other species. So I do see possibility for a future where we have strong enough global governance and we have a human population that is somewhat lower and less incompatible with the land use and other needs of the other species that we share this planet with.
Thank you. Just to follow up on this, I see a link with our willingness to terraform Mars. And in your opinion, what will be more sustainable on the long term? To preparing the future human bodies by adapting them to live on other planets, or to modify another planet's surface and environment with the risk of harming organisms that potentially live there?
Yeah. So first of all, in terms of the ethics, I think we don't know enough to know if it's a good idea to terraform Mars yet, because we don't know if anybody's living there. And it certainly changes the ethical equation if Mars has life or is lifeless. In my view as a planetary scientist, and for reasons I won't fully get into now, I don't think there's life on Mars. I think there may well be evidence of past life on Mars that would be very significant to find. But if I had to guess, I'd say Mars is probably lifeless now. But we don't know. And I think we need to explore it very carefully and very thoroughly before we make any decision that we're going to change Mars in some way. So that ethically, it would be a bad idea for somebody to say now, oh, we're going to start to terraform Mars. The good news is that we really can't terraform Mars now. We just don't know enough how to do it. So it's not a decision we have to make right now. But in the long run, it's an interesting question. If Mars turns out to be lifeless, would it be a good idea to try to change it to be more Earth-like? On the one hand, you know, there's this sort of ethic of like, well, we've screwed up the Earth enough, let's leave other planets alone. But interestingly, if you follow the ethic of deep ecology, where what you care about the most is life and the survival of life, then you can turn the ethical argument around and say, well, if you've got a vacant lot next door, and you've got a beautiful garden, don't you want to throw some seeds over the fence and start a beautiful garden in that vacant lot of Mars? And then also, what if the garden that you have is home to some endangered species that only live in your garden and could be wiped out if something happens to your garden? And don't you want to spread them to the vacant lot next door? Well, arguably, all life on Earth are those endangered species that only live in one garden. So if you really care about the long-term survival of Earth life and you love the biosphere, there's an ethical argument to spreading life to other planets. You know, I'm reducing a very complex discussion to a few platitudes right here. But then the other part of your question, would it be easier to change Mars or to change humans if we ultimately want to go live there? That's a really interesting question. I mean, I think both are ethically fraught. You know, I think we naturally think of changing the planet because we sort of like the way we are. And the idea of engineering humans to be different in some fundamental way sort of rubs us the wrong way. Because you can see, you know, what could possibly go wrong if we start re-engineering the human race. But as far as that, you know, putting the ethics aside, your basic question of which would be easier, I think it's quite possible that it's going to be harder than we think to re-engineer whole planets and build new ecologies where there weren't ecologies, and that re-engineering species ultimately may be easier. I mean, we just don't know. We're babies on all these efforts, and I think at this point, it's incumbent upon us to at least understand more about planets and understand more about how life interacts with planets, because we live on a planet and we're struggling to do a better job of interacting with our biosphere. And, you know, sort of fortunately, some of these tough ethical decisions we're discussing are things that will be left to future generations who will hopefully know a lot more than we know now.
Thank you for this very interesting perspective, David. The last question is asked by Daniel Porras, and I fully agree with him. We see a trend we find very curious. It is about people denying science and refuting experts' arguments. They are rather convinced by YouTube videos, for instance. Daniel's question is, how do we communicate with these people who are skeptical of science to develop strong policies?
Yeah, now this is a very vexing question, and if I knew the answer for sure, I'd be out, you know, standing on a soapbox and or I'd be running for office or something. It's something we're all very concerned with, and it's you know, it's been with us for a long time. Carl Sagan wrote that book, The Demon Haunted World, in the early 1990s, warning of of a future world, which arguably has come to pass now, where respect for expertise is on the wane, and that makes it easier for charlatans and hucksters to, you know, sell false and dangerous ideas. You know, the internet, maybe it's in its early days as this sort of Wild West phase where we haven't figured out how to use it well. It's such a double-edged sword, you know, this connectivity we have now, where we have, I mean, I have in the palm of my hand here this device where I can access so much of the knowledge of all of humans and all of human history, and I can instantly communicate with you sitting here in my basement, safe from a pandemic and almost safe from tropical storms, although not entirely, and communicate with you sitting elsewhere in your homes. I mean, it's wonderful what we have, and yet the use of it for garbage and misinformation, I think it's taken us all a little bit by surprise. Like I said, Carl Sagan warned about it, but recent turns have really made us aware of, you know, the sort of resistance to expertise and the those with vested interests spreading misinformation. And we're sort of in a battle now. It's, you know, which H.G. Wells called the race between education and catastrophe. It's accelerated. And I don't have a great answer to this other than saying, you know, obviously education is important. And those of us who feel as though we do have access to real scientific truth have an obligation to speak about it and communicate it as clearly as we can through all the channels we can. And, you know, I like to think that we are in early days of the internet, and just as when other forms of communication came out. I mean, you can find people talking about radio when radio was new, and how all kinds of craziness was being spread by radio and how it was going to ruin the world. And yet ultimately radio became more of a force, I think, for connectivity and spreading of information and for good than a force for destructiveness. And so maybe these tools, we just need to continue to refine and learn how to use them better.
Thank you very much, David. I know I say the previous question will be the last one, but one of the participants just shared something very interesting. Will you have time for a bonus question?
Sure. Bonus round.
The question is about the fact that DNA contributes to the transfer of information and increases its efficiency by evolution. Do you think this universal property of the universe is leading it to some finality goal?
Oh, interesting. You know, this the question reminds me of the ideas of Teilhard de Chardin, who is certainly an interesting thinker who I've been influenced by, who came up with this idea of the noosphere, and the idea that on Earth the geosphere had given rise to the biosphere, which in turn gave rise to the noosphere, the sphere of knowledge affecting the planet. And that obviously is closely connected with these ideas I was talking about the Anthropocene and the Sapiezoic. Teilhard also thought that we were evolving sort of towards something that he called the omega point, which sounds a little bit like what the questioner is asking, is the increase of information and evolution and increasing complexity leading the universe to some kind of goal. That, you know, nobody knows, but I think it's plausible that the kinds of processes happening on Earth are happening elsewhere on the universe. I mean, we're such babies. We know so little yet about what's going on beyond Earth. We've just learned, I mean, like that, just learned that there are other planets beyond our solar system. That's new knowledge in this current generation. And yet so now when you look up at the night sky, you know that all the stars have planets. We didn't know that before, but we're still at this early stage where we know nothing about any of those planets. I mean, a few of them, we know what their mass is and maybe what their climate's like, but we don't really know anything about what's happening on all those planets. So it's possible that what's happening on Earth is a very widespread phenomenon where the increase in complexity and even intelligence and thought and self-awareness is something happening elsewhere in the universe, and something that ultimately can expand outwards. And then the universe as a whole might be becoming more aware and more conscious. So I don't know about leading to some ultimate endpoint. That to me is verging on theology more than astrophysics. Although if you take this line of thought far enough in that direction, the two sort of merge and you get to astrotheology, which in a sense is what I wrote a chapter about that in one of my books. Astrotheology is a sense is what we're talking about here. So I do think it's possible that the universe as a whole becomes more permeated with intelligence and consciousness and sort of more self-aware. And maybe that ultimate endpoint is a self-aware cosmos. I kind of like that idea, but I would also say that we're far too ignorant and too early in our understanding of the universe to really know if that is the path of the universe that we're on. Although it's certainly something to keep exploring and try to understand.